That is pretty cool. Today is 10th of October 2025, Friday, and we will continue solving questions at a rating of 1500. Yep, that is the intro. Stop this. Stream is excellent. Yep, cool. Problem sets. Problem set, not plural, singular. And we go 1500. And let's make the goal actually achievable. Yesterday we did like 4 questions. Let's today go up to 6, 5, 5 at least. 1, 2, 3, 4, 5, and not like this. 1, 2, 3, 4, 5. And we will also note the time that it took us to do these questions. Stopwatch, and also this thing, and a few things I would say. If no idea, 1 point. If no idea in 30 minutes, then read the editorial. Right? That makes sense. If no idea in 30 minutes, then we can read the editorial, and that will be it. Yeah. And yeah, that is kind of it for the introduction or whatever it is. And let's begin. Hello. I won't be able to Jennifer few days because I am also doing C++. What do you mean, Jennifer? Uh, keep eye up. I think grammar messed up a little bit. Grammar got messed up a little bit. Okay. And we can maximum subarray sum. Shit. There was a question earlier, a few days ago, in which it was, yes, it was in the last contest. Yes. Code Forces last contest. Question number C. Educational round. Question number C, supposedly this was, yeah, in this question, we had to find out a way. Yeah, in this question, we converted A's into +1s and B's into -1, or we could do vice versa. And then we had to find the smallest string, which would give us a certain sum in that array of 1, 2, of characters -1 and 1. Yeah, that was it for that question. And this one seems a bit similar. Let's do this. Okay, you are given an array A to n of n length and a positive integer k, but some parts of the array are missing. Our task is to fill the missing parts so that the sub-array sum of A, sub-array sum, maximum sub-array sum of A is exactly k, or report that no solution exists. Formally, you are given a binary string S and partially filled array A, where s equal to 1 indicate that you are given a real value. Otherwise, if you don't remember the value of ai, si equals 0, indicate that you are given ai equals 0, all the values that can be satisfied. Ai can also be negative. However, you may use maximum subarray sum. However, you may use values up to 10 to the power 18 to fill in the values that you do not remember. It can be proven that if a solution exists, also exists satisfying this condition. Maximum subarray sum of an array is a subset of these arrays where we are taking their sum. First line n and k, second line the string s, and then the array a. So maximum subarray sum has to be k. Poor. That is very poor. Maximum subarray sum has to be k. what is the maximum subarray sum right now? That would be nice to know. Here we have two numbers, this and this. Okay. If what is the maximum subarray sum right now? If this is our total array and our maximum subarray sum is, let's say, in this some range, it exists in some range, then in that range, if there is a number that is unknown, and let's say this sum, there could be a few possibilities. If the sum, this s currently, if it is already equal to k, then we can just fill all the values which are not there with 0. If this sum is smaller than k, then also it will be easy. If we if there is a like unknown value in this range, then we can make that value equal to k minus s, and we can put that value equal to k minus s, and this would still be, let's say there is this value does not exist, and the sum of this maximum subarray with some values missing is smaller than k, then we can make this value equal to k minus s, and the sum of this thing goes up to k. And now, is this still the maximum subarray? Maximum subarray sum? I think yes. This would still be, because this s, as we know, is initially the maximum sum, and we are adding something, some constant number to the maximum number, and all of the sub arrays, all of the other sub arrays are also getting increased by this much amount, which do contain this element, and their sum is getting increased by this amount, and the maximum sum s is also getting increased by this amount. So relatively speaking, they would still be smaller than the maximum sum, so cool. But it could be also the case that there is no unknown value in this range. There is no unknown value in this range. What do we do then? That is a nice question. If there is no unknown value in this range, then we have to do something. We have to change the sum outside. Why do these questions feel hard? Okay. And the only degree of freedom is those unknown cells. They are the only degree of freedom that we have. Those unknown cells. Uh, Let me post the question also. And I still don't get what this means. I won't be able to Jennifer few days because I am also doing C++. Okay. And if our degree of freedom is not inside the current maximum subarray. Okay, let's talk about the case when it is. Okay, let's say throughout our whole array, there is some array which is giving us the maximum sum. In that case, we can, in that case, there could be a few cases, s equals k, S, this sum, maximum sum currently, S is smaller than K or S is greater than K, and we are saying that one of the elements in this is unknown. If S is equal to this, then we will put all of these elements equal to 0. If S is smaller than K, then we will make one of the elements equal to S K minus S. But if S is smaller, we need to decrease the sum of this subarray, and we would like to add a negative number here. If we would like to add a negative number, but if we do add a negative number at a unknown place, then that is not very good. If we add a negative number, then the sum S, shit, this is the maximum sum. Yeah, this will be reduced. Maximum sum would be reduced, and then we would have to see what is the new maximum sum, because the new maximum sum might be still greater than K, greater than K. Yes, S dash. S is no longer greater than K because we have added some negative number in here, and we must add a negative number in here. And yes, shit, if a lot of things are unknown, and in this case, we have changed one of the unknown strings, which we must change. But then we cannot say for every zero, for every unknown character in the string, we are going to change it. That does not make sense. Yep. Even though we can, if you want, we can, using Cardan's algorithm, calculate the maximum sum subarray in a linear pass through the array. So that is, wait, okay, do we use binary search? Because let's say we are making all of the unknown elements equal to some number, like, okay, we can make all of the unknown elements equal to some number, but no, it won't work. Yeah. When, let's say, we have a string of 3 characters. If we have a string of 3 characters, nah, binary search won't work. And let's say k equals to 2, and making all of the elements equal to one number does not work. Yep, it does not work. So we have to do something else. Hello, how is everything going? So, yeah, let's look at one of the examples here. The current maximum sum is 1 in this range, and what we want is the sum to be 5, and this is the only value which we can change. This is the only value which we can change, and yes, this is the only value which we can change. This can go up or down, and currently the maximum sum is 1. We need to bring it up to 5, and we have to add 4. We can just add 4 here. The maximum sum is this much now, and it does work. That does work. But this only works in the case when our current maximum sum is smaller than the required sum, and one of the elements within that sum has a value, has a unknown value. We can just make that one number equal to the difference. We want to get to k, but currently we are at s with s, which is a smaller number. So we can make that unknown value equal to k minus s. But this only works when s is smaller than k, when k is greater than s, and in this s range we have a unknown value. This only works then. Here everything is known, we cannot do anything, and the current maximum is actually equal to 5, which is what is required. So yes, here we cannot change anything, so no. And already the current maximum is 1. Here we want the sum to be 10, and the sum already is 10 maximum sum. So we can make these numbers equal to -10, and this would work. Or -20 or -30, anything greater, smaller than -10 or equal to -10. Here we want the sum to be equal to 19, and the maximum sum is this much. And yeah, 6, we can make one of these elements equal to 13, or make the sum of these two elements equal to 13. Yeah, 6 plus 7, 13. Here nothing is known. So the answer depends on what is the degree of freedom that we have. And in this case, we can only change one of the elements, which is this, and the current maximum sum is this much. Yeah, the current maximum sum is 3. We can treat these zeros as separators. We can think of these zeros as separators dividing this much and this many things. Now 8 plus 5, 13 plus 3, 16, and we want the sum to be reduced by 3 to be equal to 12. But here in this range itself, we have a sum of 14, like maximum sum 13. So yeah, so and we cannot change anything in this, so answer would be no. For the fourth case, 1, 2, 3, 4, no. We want the sum to be 4, we can make one of these equal to 4, and the other one can remain 0. One number is unknown. Yeah. What things affect each other? If we treat this and this as different segments and this as like a separator, then the maximum sum in this segment is 4, and the total sum of this segment is +1. And here the maximum sum is 1 and the total sum is -1. And we want the total sum to be equal to 6. Yeah, the order would also depend. If this 4 were here and this 6, 3 minus 3 was here, then we would just make this 0 equal to 2. But now we have to do something else. Now we would have to make this equal to 3. we will have to make this equal to 5, and then this total sum would be equal to 6. So the order also matters. Maximum sum subarray. And we can use the Cardin's algorithm for this, not Kardashian's. Cardin's algorithm for maximum subarray sum problem. But that is not the problem. The problem is to make the maximum subarray equal to some number. Something stopped working. The mouse thing stopped working. I have a app which can configure how the mouse works, and it has stopped working. Where is it? Like, it is right here. This one, this little thing. What is going on, and why am I watching LOL? Yup, we are just trying to solve a problem here. And if you are from a CS background, then this problem is called not Cardin's algorithm specifically, but here we have a vector, an array which has some numbers, and some of those numbers are missing. And what we want is the total sum of a subarray to be equal to this number. Like, if you choose any subarray from this final array after fixing in the missing numbers, the maximum sum of a subarray cannot exceed this. It has to be exactly equal to this given number. And this is a tough problem. Yeah, maximum sub array sum. And that thing is literally not working. The mouse thing. Okay. And I am not having any ideas about what is Cardine. Hello, good afternoon. And shit, yes, it is afternoon. And Cardine's algorithm. You can use Cardine's algorithm to find the maximum subarray sum in like linear path. Let me actually apply it. Hopefully the spelling is correct. Kadane. Cardines. Hello.cpp. The code. Cardines. Algo.cpp. Boilerplate. And NCNN vector a size n for int reference x in a taken x. The array is full and maximum sum is something, and current maximum is also something. And then we will start iterating from the start of the vector I less than n, I plus plus. And what we do is we will see if the current element ai, if the current element is greater than the cmx current maximum plus the current element, then cmx equals ai plus cmx. Wait, shit, I messed up. If the current element plus cmx is greater than the current element, then we update cmx as this, else cmx equals ai. And at the end, like overall general maximum is going to be equal to the whatever the maximum has been till this point and the current maximum. And a new line And let's use this. We have one test case which has, let's say, 10 elements, and we can use chat GPT elements -2, 1, -3, 4, -1, -3, 4, -1, 5 elements, and let's say 1, 2, 3, 4, -10. The total maximum sum is 13, and it should be 13 in this case when we have 4 plus 3, 7 plus 3, 10, 10 plus 3, 13. Shit, yes, that is the maximum sum, 13. So yeah, in a linear path, you can find the sum which is giving you the maximum sum array. Yes, shit, I messed up. Don't know what is happening, but keep it up. Okay, I will keep it up and be lucky. Shit. But wait, you have Kakashi. Is that like Kakashi? That is Kakashi. Shit. That is pretty nice. Bro, I have a problem for you. Can you answer if you have infinite supply of two unique numbers? Then what is the largest number you can get with these two numbers? What do you mean? I have infinite supply and I can add these numbers to each other. If I can add these numbers to each other, I can just keep taking the numbers. I'm in third year, fifth semester. If I can add these numbers, I will just keep taking the numbers and keep adding, and I can make the sum infinite. And if the numbers are negative, -2 plus -2, unless the numbers are negative, if both of the numbers are positive, then the sum will be always positive and I can keep taking them. Yo, let's go. Bro just started. No, you cannot make all the numbers. Let's say, okay, what are all the possible sums I could achieve? Numbers are 3 and 7. How will you make 1? Okay, I thought you said what is the largest number I can get. Okay, 3 and 6, 3. Crazy guess. It seems pretty random. What is the largest number you cannot make? That would be among the two numbers. What is the smaller number? -1. Read spelling. Shit. What is the largest number you cannot get with these shit? Okay, my bad. That would be, I guess, the smaller number between the two, -1. But also, yes, this depends on the degree of freedom. Hmm. Largest number we cannot make. What would be the largest number we cannot make? In this case, when we have 3 and 7, we cannot make 5, we cannot make 10, we cannot even make 13. Wait, we can go to 13. 7 plus 7, 100. Can we not make 100? Okay. Whatever the possible sums are, they would be in this form, 100. Uh, let's say x and y are the two numbers, and we have a amount of x and b amount of y, and this equals some c number. So what is the largest value this c can have? What, like, shit, what is the largest value that this c cannot have? That would be c minus 1 if one of these, and this is like also feels like Diophantines equation we did at some point. Yeah, random shit. Shit. I have seen a question like this in CSCS. Yes, in CSES. No, maybe not in CSES, but somewhere. This, like, literally, this equation is Diophantines equation, and this equation is Diophantines equation, and it is easy to find out what A and B you should choose to get to a number, but what C is not possible. The biggest value of C, that is not possible. Hmm. The biggest value of C that is not possible. That is crazy. Your uh, rank is currently rating is currently 1400, 1417, and I hope to increase it up to 2000, and hopefully by the end of this year. That would be amazing. A into B, A into X plus B into Y. A and B are integers. Okay, this depends on the degree of freedom that we have. If one of these numbers is 1, then we can make anything. If one of these numbers, let's say, is 2, then we can achieve all of the odd multiples. Okay, let's say we do not have two numbers. Let's say we have one number. In case of one number, let's say our number is X, then the largest, then what are the numbers that we can achieve? We have, let's say, X in infinite supply, and we have A amount of X. In that case, we can make all the multiples of X, where A here is a, like, integer, positive integer. So if X equals 2, or let's say begin from the smallest, when X equals 1, we can achieve 1, 2, 3, 4, 5, any number we want till infinity, because the degree of freedom is like a lot. The precision that we have is cannot be more than this, right? And now if X equals 2, we do not have a lot of precision. We can have a sum of 0 when we are not choosing anything at all, and in the above case also we could have a sum of 0, and then the next smallest sum that we can have is 2, and 4, 6, and dot dot dot, all the even numbers till infinity. And in this case, shit, this biggest number that we cannot have would be the biggest odd number, which is a crazy question to ask. Yeah, so in this case, we would have a amount of X, and the next number which we could achieve after AX would be A plus 1 into X. That is, we had one more X, and let's say this A is as big as possible. In that case, A plus 1 into X minus A into X. This is the difference, which is literally X. So yeah, every number that is not achievable is also changing by X amount. Here, 1 was not achievable, and the next number which is not achievable is 3, which stand at distance of 2, and then the next one is 5, then 9, then 11, and boom, 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 13. Okay, so in one case, and when we only have one number, then it is pool, right? Answer would be infinity. But shit, two types of infinity. If positive infinity or negative infinity, when X is 2, we can achieve every even number. And yes, I completely forgot about the question that we were doing, but okay. If X is positive, if X is even, then we can achieve every, if X is 2, in this case, let's say X is 2, then we can achieve every even number, and the biggest number that is not achievable would be the biggest odd number that is also infinity, and we can also achieve infinity if it is even. So which infinity? If infinity is the answer, odd infinity, even infinity, the parity. Shit. Okay. Now let's bring two numbers, and yeah, let's bring two numbers. Then what is in the above case, we were able, the next number that we have to get was at a distance of x, and here the distance has changed. Yo, yeah, in the TLE, but in that we had to make the sum equal to a number, but okay, hearts. Yeah, okay, the question was in TLE, but in that we had to make the sum equal to a number, but the number should not be divisible by a particular number. Let's say k. So this was in TLE. Bro, using 1 and 2, you can get all the numbers from 0 to infinity. Yep. Wait, I said when we are considering only one number, that is, I only have one, then everything is possible. And when I only have two, like there is no other number. So which number didn't you got? You didn't got. Yep. When we have only one number, the difference between the next achievable number is changing by the number x. But if we have two numbers, then the degree is shared. How do we even calculate the degree of freedom? These numbers would have a shit GCD. C depends on GCD. Yes, I remember. C depends on GCD. C depends on the GCD. And should we cannot have these numbers in negative. We cannot have these. Shit. Yes, yes. Now I remember. Now I remember. C has to be, like literally has to be a multiple of GCD of x and y, greatest common divisor. And in this case, which you gave 3 and 7, the GCD of 3 and 7 is 1. So GCD is literally the degree of freedom that we have. GCD is the degree of freedom that we have. Uh-huh. Yep. GCD is the degree of freedom that we have. And hmm, can you achieve a sum of 0? I think we should always be able to achieve a sum of, well, literally when we are not used, when a and b both are equal to 0, we can achieve a sum of 0. But here, when normally in a Diophantine equation, we can have a and b as negative numbers. So when you have 3 and 7, it is called Frobenius, that could be a Greek person, that is German. Shit. Here, George Georg was a German mathematician best known for his contribution to the theory of elliptic functions. And he was born in 1849. Shit, 1849 is a special year. Went to jail. Dostoevsky went to jail in the year 1849. So 1849 is one of the most chaotic years for him, and thus for us also. I think, yeah, GCD. So what would be the smallest sum? since we cannot afford to have a and b as negative numbers, and we know that GCD of x and y, okay, let's do this. GCD of x and y is going to be equal to or smaller than x and y. Then we can achieve a sum of x and we can achieve a sum of y, right? If the GCD is not equal to 1, but not that. Shit, you cannot have negative a and b because we have coins. We have coins. Coins cannot be negative. You can be in debt, but we have coins. And the mouse extension is just not working. Where even is it? Shouldn't have happened during the stream. This does happen from time to time. There is an extension which I use to zoom in and zoom out during the stream using the mouse, but it is not working right now and the extension does not even exist. Key, it should be, no, okay, okay, I will fix it after the stream. Yeah, okay, and shit, this is one of the problems in CP31. So it means we have done that problem earlier, but I am unable to do this now. So that is crazy. I will take a screenshot and we will look at it and I will figure this out. And for now, let's get back to this question. Maximum sum subarray and Cardane's algorithm. And literally, I do not have any idea, so it is okay to look at the editorial. And shit, I do feel bad, but we do not have to feel bad. The main goal is to learn, right? Yes. Wait, am I like shit, messing up? If I cannot think of any ideas here, what could we do? Okay, we can look at the editorial. It is fine. It is fine. It is fine. It is fine. We are learning. It is fine to look at the editorial. We assume that there is at least one. Okay, before reading the editorial, let's write down what we do know. Right? Okay. Uh, if no zero and max sum is not equal to k, then like not possible. That is one thing that we know for sure. So we can expect to see this in the editorial, and also the fact that we did just read a bit of the editorial and this line was literally the first line. Okay. Shit. Yep. So this is one thing, and also another thing which we were able to figure out is that if max sum is smaller than k and range in which we have the maximum sum has 0 or unknown element, and then it's easy, then we can do this. And I don't think we were able to figure out anything other than that. Yep. And one more thing I would like to add is if max sum is already equal to k, then also Does not matter if we have a 0 or not, we can put everything equal to 0, which is like everything which is unknown, we can put it equal to 0, and the answer is there. If maximum equals k, put all the 0 to 0, and yep, that is done. But yes, and also another case, if maximum sum, the current maximum sum is greater than k, and range doesn't DOES doesn't as 0, then not possible. Then the answer is like literally not possible, because we do not have any freedom on this maximum sum. But the thing after this is that if there is some 0 element which is unknown within this range, let's say we do change it, then another array, another subarray is going to have the maximum sum, and that is bad. Or shit, all of the elements in this range, we can make them equal to minus infinity or something, and then if we do make them equal to minus infinity, let's say, just let's say, then we would get to this condition in which, yeah, then either we are still in this condition that the maximum sum is greater than k, or we get to this condition when the maximum sum is smaller than k, and we do have a 0 in that range. And that is nice. But if we do not have a 0 in this range, we might have a 0 somewhere else, and we will increase the answer. Wait, shit, if the maximum sum is actually smaller than k, then wherever the 0 is, where, okay, let's be a little bit more methodical. If max sum is equal to k, this is one case. If they are equal, then then it is already done. Yeah, that is trivial. But if max sum is greater than k, if max sum is greater than k, then what we will do is turn all the zeros to int minimum number. That would be a very negative number, and hopefully we would have a case where maximum sum is smaller than k. And if this is the case, then we just pick one element that is equal to 0, and we will keep increasing its value, and we will make sure that the vectors, or that the range in which it affects the maximum sum, it does not exceed k. I think this one is much easier to handle, and we do have the choice of converting this condition when the maximum sum is greater than k into into this condition when the maximum sum is very small than k. And still, even if after turning all of the unknown elements into minimum integer value, we are still at this condition, or we can begin by converting all of the zeros into int minimum, and we can check if the maximum sum is greater than k. If, yes, okay. We can convert all of the unknown numbers into int minimum. If the maximum sum is not already equal to k, we can convert all of the 0 unknown numbers into minimum value that they could have, and check among these two conditions. If this condition, then false. Answer is not possible. Red. But if the maximum sum is smaller than k, then we will change one of those zeros. We will see how many zeros were there in the original vector, which we changed into something else to get here. Do you want to analyze? It is not in CP31. Okay, that is different. And it was not written where I read that it has to be unique prime numbers. Now I searched and got to know this because the solution is a into b minus a minus b. But if use 2 and 4, then using this formula, answer is 2, which is wrong. And the total positive number that cannot be attained is a minus 1 into b minus 1 divided by 2. And the total positive number that cannot be attained. If a and b are shared, okay, when you are saying this formula only works when these two are unique primes or at least co-primes, then a into b would be their LCM, right? And when you do a into b minus a, that is just, you can take a common from these two equations and you would get a into b minus 1, a into b minus 1, and that number is not a factor of b but is a factor of a, and then you subtract b from that number, and that number is also not a factor of a anymore if a and b are co-primes. So that makes sense. That makes sense. LCM. So this is sort of like LCM minus 1. Sort of like LCM minus 1. But this is the general formula. What if a and b both are even numbers when we have 2 and 4? 2 minus 1, 1 into 3, 3 divided by 2, that would be 1, 3 divided by 2, and 1 is actually the answer, but 3 is the answer in this case when we have these two numbers. This is a nice problem. I will keep this in mind. And in this case, okay, now we have changed our original problem into this problem when the maximum sum is smaller than k. And when the maximum sum is smaller than k, let's take one of the examples. If hmm, when the maximum sum is smaller than k, then we do know exactly how much amount should be increased totally. I think we have the total sum. We can have the total sum. Ah, shit. Okay, let's look at the editorial. That would be nice. We are spending a lot of time on this problem. See this. See, we assume there is at least one SI equal to SI equal to 0 unfilled position. In the other case that all Si equal to 1, we can easily check if the maximum sum is k or not. Yes, let us first figure out when the answer is impossible. Replace shit. Okay, that is literally what we figured out here. Turn all the zeros to int minimum. Replace all ai equal to minus infinity such that ai si equals 0. The maximum sum array is still greater than k, then the answer is clearly impossible. Yes. In every other case, the answer is in fact possible. Okay. Answer is possible in all the other cases. Okay. All positions with si equal to 0 will keep minus infinity except for 1. Choose that position arbitrarily. Let's call it pos. Then linear or binary search. There are two options we could go with. Let b equals max prefix sum from that position plus 1 till the end. Max prefix sum. Okay, makes sense. Okay. That would be how much this current element will extend to the right. Let C. Shit. Okay, I get it. Okay, we can do this. We can do this. I got the idea. No, not today. Because yeah, I have to like practice a lot more. I'm struggling with 1500 rated questions, and yeah, I have to just practice a lot before giving any contest. What I'm actually aiming for is to increase the rating by 100 points and get to 1500 in the next contest whenever I give the next contest. And that would be pretty cool if I could jump 100 points. Then we have a string s and vector n a size n for int x c in x, and yes, we have everything. If and int cnt equals count the number of zeros a dot begin and a dot end, count the number of zeros unknown elements, and if some elements, then we will do something. But if there are no zeros, the flexibility is like messed up 0, then we apply the Cardane's algorithm which we just wrote. Cmx equals 0, and in a single pass int I equals 0, I less than n I plus plus. If ai is greater than cmx plus ai, then cmx equals ai, else cmx current maximum equals ai plus cmx, and at the end we will have mx equals maximum of current mx or maximum of what has been if maximum is not equal to k. Shit, I mixed up. There is another number here which we have to take in, which is k. If mx is not equal to k, then C out. No, a big no. Or C out depending on mx equals k. If it is equal, then yes. Otherwise, no, with a new line and then return from the function. Else, if there are some numbers, then for int I equals 0, I less than n I plus plus. If si equals 0, the current element is unknown, then ai equals n minimum, and it would be really helpful to convert these integers into a long. Mm, yep, and also these substitute integer to long, and yeah, that is pretty nice. After that, uh, yeah, convert everything to a integer minimum, and now apply the Cardin's algorithm again. It would be much better to have a function Cardin. This takes in just a vector of long a reference a long mx equals 0 and long cmx also equals 0. Then we will start to iterate for int I equals 0, I less than n, or where int n equals a dot size I plus plus. If ai is greater than cmx plus ai, then cmx equals ai. Otherwise, if that is not the case, then cmx equals cmx or cmx plus equals ai, and maximum equals maximum of what has been or the current maximum, and then at the end return the maximum number. And now we can spare ourselves this much work, and here say long mx equals Cardin and pass in the a vector, and yes, that is nice. And after this, here again long maximum Cardin a. Now if mx greater than k, then crazy. If mx is greater than k, then see out no, and return from the function. Otherwise, yes, we can choose any integer arbitrarily, any of the element. Let's say auto it equals s dot find a 0. This is going to give us, or let's say int x. This will give us index for one of the zeros, index for one of the zeros in the s string, s minus s dot begin lsp start. Let's see if the syntax is correct. Syntax is not correct. Find 0. What does find 0 return? Find 0 returns size, size type. Uh, Find 0 returns size type. That is crazy. Yo, bro is giving the contest. He is very cool. Int x equals s dot find 0. Okay, get the index. And yes, x will have the index of one of the zeros. Then we need to see how much this is extending towards the right and how much this is extending towards the left, and the values are between 10 power 6 and key can be very big, which is okay. Okay, yes, we can do this. Okay, let's say mx right vector long mx right and mx, or pref r and pref l, and yes, and yeah, and the size of this thing should be x. There are x amount of numbers on the left of the x index, or x plus 1, because this is a prefix, and shit, this is right. So on the right, how many numbers we have? We have n minus x. Yeah, we can make the size n minus x, where x is 0 index and n is not 0 indexed. N is the total number of elements. And on the left, x plus 1, and we will fill these prefixes. For int I equals x plus 1, I lower than n, I plus plus, pref shape. Let's begin with I equals to 0. For int I equals 0, I less than I plus x plus 1. Yes, less than n. Yes, less than n, and I plus plus. I plus 1 equals pref shit, which prefix right, find f prefix right, prefix I plus the last prefix plus, from a we are getting the value I plus x plus 1. Cool. And also we will keep track of what the maximum value is. Long mx r, and mx r equals maximum of mx r, or prefix r I plus 1. Okay, cool. And we will now do the same thing for left. And left is easier to handle. I less than x, because we are not going up to x, I plus plus. And pref L I plus 1 equals prefix L of I, the last element, plus the current element, which is exactly AI. And also mx L. Initially, let's give both of them value equals 0. Okay, should now it is better, I guess. mxl equals maximum left mxl, and prefix li plus 1. Now, what we need to make this current element equal to would be ax, now is the final thing, equals what we lack, which is ai, what we already have, what we already have, what we already have. K is what we need, and what we already have is mxl plus mxr plus ax, the current value of ax, which is currently speaking equal to int minimum, int, and then see out yes, for int I equals 0, I less than n, I plus plus, see out ai, and then space or a new line depending on I equals n minus 1. This will say wrong answer. Shit, that is actually crazy. Shit. Where did we go wrong? Okay, Cardine, what? See out MX. It is Okay, we are exiting before that. We are, if not CNT, that is if CNT equals 0. Shit. We are looking for this in S. Okay, yeah, things are much better now. Hmm. Yes, let's make the yes and no smaller case. Shit, okay, and let's use a vim command to do this. Uh, in this range, apply globally, match a pattern. Yes. Shit. Let's do in the whole file, substitute capital YES with the small yes, and again with the in the whole file, substitute capital no with small no. Yes, and here everything is amazing. And here we say this, and at least yes and no are matching, except in this case we didn't even say yes, which is true. Shit, depending on yes, okay. If mx equals a, then we output yes, L, C out, no, is small, and here C out, yes, and a loop for int I equals 0, I less than n, I plus plus, C out, AI, and then string space or new line depending on I equals n minus 1. Okay. Here is this matching. This is certainly literally matching. And is this matching? Here, what we are saying, okay, these two elements will, of course, not be counted, but these two will be counted in the final answer, and it turns out to be 15. And is 15 the number that is required? Well, 19. Wait, shit. The maximum sum would turn out to be shit. Okay. Yes, one more case. We have to consider here one more case. Not one more case, but the values of mxl equals maximum of mxl comma 0 long and same mxr equals maximum of if, because if mxl and mxr are 0, then we won't have them in our final answer. We won't like add them to our answer. And now here 6 plus 19, so that is 25, and here we have shit. Yes. Yes. When we are looking for the maximum sum on the left, we have to move from right to left. But currently we are moving from left to right. And that is kind of messed up. Which is here. And this wouldn't be a problem. But here it is. Okay. In this case, we begin from x minus 1 while I smaller than, greater than equal to 0. No, let's keep this as it is, and we'll change how we are indexing this. X minus 1 minus I. We'll see what we are adding, and as I increases, X becomes smaller and smaller. Now we should be like happy. Yes, we are happy. 13 plus 6, that is 19. And in this case, we do have 19, which should be the required value. It is the required value. And in this case, the required value is 12, which apparently is not possible. And in this case, before this, and the answer is possible, the required value is 4, which is the correct answer. And this is crazy. Okay, and let me contemplate this a little bit more, because here the answer is possible. And since at this point, when we are here, we know that the maximum is not greater than k. So does not matter which x, which 0 we go with. We will have, yeah, we how much it extends to the left and how much it extends to the right is going to be smaller than k. And whatever that is, that amount, that small amount is, we just need to add whatever is required here. And that is very nice. That is very nice. That is very nice. Cool. And yeah, let's see if this is working. Submit, copy paste. Seems to be working. Seems to be. Yep. Okay, shit. Wrong answer. Wrong answer. Wrong answer. We messed up somewhere. Messed up somewhere. Count. Okay, we get the count of 0 in the S string, and if count is 0, then we use the, wait, it might be a overflow here. Here, it is not a overflow. Yes, cannot be a overflow because we are using long, and the maximum amount of numbers we could have is 10 power 6. And let's say every number is as big as it can be, which would be 10 power 6 into 10 power 6. We have a number that is 10 power 12 long. In that case also, everything checks out because long can hold a number up to 10 power 18. So yeah, we are happy. And then A is long, X is long, count is integer, that is nice. Exact. Yeah, okay, that was the mistake. K was not long. Is there anything else? K, because K can be 10 power 12. K can be equal to 10 power 12. Yeah, shit, that was a obvious mistake. And anything else? We are using an integer here. That is not a mistake. We are using an integer here just for indexing. Int. This is also index. Cool. Everything checks out. It should work now. Let's see how it goes. Yo, just started out in CP. Any suggestions where to begin? I mean, yeah, I do practice on CodeChef. Okay, so accepted. That is nice. Okay, if you want resources, then, and since you already are practicing on CodeChef, if you want you just need two things. You need questions and you need a place to read up theory. And on questions, if you can have a structured guide, that would be very helpful. And for a structured guide, you can go to TLE eliminators and start solving these questions starting from a rating of 800, and you can keep going up at oh, yeah, until 1900. And yeah, this is a structured way to get questions, right? So you do not have to manually go and look for questions. So this, you can use this for practice. And then there is this book, Competitive Programmer's Handbook, which you can use for theories. And this should be enough to get you wherever you want. Like till a rating of 2000, this book is sufficient. Like the material which is here, it is sufficient to reach a rating of 2000, in my opinion, IMO. Yeah, if you do not get anything, then you can look up additional resources. But yeah, the only reason that you might use something else other than this book would be that you do not understand what is written in this. And that is okay. Then you can look up some YouTube videos for some specific topics which you are unable to understand from this book. But the main thing is, every topic in this book either does not matter how it is explained, but it is enough to get you up to a rating of 2000. And that is nice. You you can use this book as a index at least to get to know whatever topics are in dynamic programming or in competitive programming, and that is nice. That is what I would say. Okay, and here in the editorial, they also said that there is a binary search solution to this. Binary search solution to this. This is linear solution. And then there is a binary search solution which would take n log n time. Let's apply the binary search solution. So after we have index of one of the x's, then let's see. Then let's see. Okay. Long L left value can be int min, which x already is equal to, and long R. And what are the invariances? What are the invariances? Invariances is that L is L might actually be the correct answer. So we will go with in minimum -1 or 1 in 1 long into minimum, and then -1 because this might underflow. Yes, this is our left value, and our right value would be 1 long into, let's say, let's say we need a big value. Let's say int or int long minimum, long maximum. That would be too much. Say 1 long into 1e5 or 15. Yeah, just a random number. And our answer, whatever it is in the range L to R. And since these are curvy or like parentheses, answer does not exist at the boundaries. So we will keep the search while their distance is at least greater than 1, greater than 2. So while R minus L greater than 2. And when we exit, answer would be L plus 1. Okay. So, uh, long n equals L plus R minus L divided by 2. And we'll say AI equals M and long mx equal Cardane U A array. And if mx equals to k, mx is greater than k, then answer is not possible at this value and R equals M. Else, if mx is smaller than k, then L equals M. We will update our left limit, and else if it is same, then L equals M minus 1. And when we exit, shit, when we don't have to do anything when we exit. When we exit, yeah, shit, literally we don't. No, no, no. We do have to do something, and that thing is AI equals L plus 1. How does it work now? Yes, what is I? That is a nice question. If I make it equal to X, oh god, this algorithm just keeps on working, keeps on moving forward, and this, and does say wrong answer, but the answer is actually correct. Answer is correct. This is the binary search implementation of the same algorithm, and that is nice. Hello, I have just started CP. Any tips, please? That is 2 in a row. Okay, so you would need questions to practice, and you would need some place to read theory from. Yes, this looks good. This looks good. Yeah, you need two things: questions and theory. For theory, you can use this book, Competitive Programmer's Handbook, which is nice, written by Mr. Antti Laksonen himself in 2018. And this has all of the topics which you will ever need. Literally, if you are not going to cross a rating of 2000, these topics are going to be enough. And you need some place to practice, for which you can use the CP31 sheet. Here you have questions at different ratings, starting with the smallest rating, 800, and at each rating you have 31 questions. Thus the name CP31, and you can start solving questions from 800 and keep going up. That is nice. These are the two things you can use. Does that make sense? Okay, accepted. That is nice. That is nice. That is nice. Let's read binary search. That is nice. In both situations, be careful to avoid overflow. Yes, one simple way is to have infinity equal to 10 power 13, as that is sufficient for our purposes. Previous overflow, but still prevents overflow, but still larger than k plus AI. Is it large? Yes, it is larger than k plus AI. Yeah, sure. We can move on to the next question now. We have done just one question, and that took 1 hour. Shit, okay, I'll be like, okay, this is nice, this is nice, this is nice. I'm improving. This is nice. 1 hour and let's say 10 minutes. This is nice. Let's go to the next problem. Flower boy. Flower Boy. This is the next question. Amazing name. Your okay, bro is going to participate. That is cool. And laptop is going to die. Let's start the timer. Flower Boy. That is a nice name. Flower Boy has a garden of n flowers that can be represented as integers ai to an, where ai is the beauty of the ith flower from the left. Igor wants to collect exactly ai is the beauty of the ith flower, exactly m flowers. To do so, he will walk the garden from left to right and choose whether to collect the flower at this his current position. The ith flower among ones he collects have must have at least bi beauty. Igor notices that it might be impossible to collect m flowers that satisfy his beauty requirements. So before he starts collecting flowers, he can pick any integer k, use his magic wand to grow a new flower with beauty k beauty, and place it anywhere in the garden between two flowers, before the first flower or after the last flower. Because his magic abilities are limited, he may do this at most once. Output the minimum integer k. Igor must pick when he performs the aforementioned operation to ensure that minimum integer. Okay, that this seems easy. This seems not easy. This seems, yeah, I have some idea. To ensure that he can collect m flowers. If he can collect m flowers without using the operation, output 0. If it is impossible to collect m flowers despite using the operation, output -1. So we will go from left to right, adhering to his beauty standards, and we will use greedy algorithm to pick the, like, we will fill this, we will, if we are at a current flower and its beauty requirements match our current beauty requirements, then we will pick that flower, because there is no point in delaying and saying that we are not going to pick this flower, because what is the point? Because we cannot come back to this current flower. So if the current flower is matching the beauty requirements, we will pick it up, and we will make the initial m array, and then we will see if the m array is already filled, then answer is 0. We don't need the operation. If the m share if the m array is not filled, then okay, which flower would we like to take? I think that is a nice question. Which flower would you like to take? Which flower would you like to take? What are the limitations? N and M can be very, very big. A and B. Okay, cool. If the M array is already filled, then okay. If not filled, then wherever we are going to input that new flower, or wherever we are going to input that new integer, it is not going to affect everything that is to the left. It is only going to affect everything that is on to the right. And we can verify if putting a flower at a current position is right or not with some certain value using binary search. Using binary search. Yes, using binary search. I think we can calculate that thing where we should put the current flower. That's some consistent work. Thank you. I will keep at it. Okay, we will see. I think we can apply binary search here and we will be able to see. But what is the thing that we are searching? Okay, we will say in the range M. Yeah, we will apply binary search in the range M and we are applying the search to find the flower which we must add. And we will add that flower at shit, not even that. We will apply binary search on not on the M vector but on the A vector and we will be putting elements in the A vector. Shit, there are literally two values. Okay, we can suppose that the integer. Okay, there are two things on which we have to apply the binary search. One thing is where we are going to input that new integer, and second is what should be the value of that integer. I think we can take the value as int maximum. That would work for every possible thing, and we can, using binary search, figure out the position where we need to go. Yeah, and if we do find a position that works for that integer, then it is cool. And if it does, then it is not cool. Okay, okay, cool. We got this. We can do this. Boilerplate, and not just n, we also have number. And then we have a, I, and then bi. Yeah, vector integer a size n and b size n for into reference a x c n x and for f a replaced with b. Yeah, we have filled both of the things, and let's write a function which tells us if the current ai value is right or not. But not just that, we would need two things. Okay, let's get int j equals 0, and then we will start iterating for int I equals 0, I less than then n I plus plus. If ai is greater than or equals to bj, then j plus plus. And yeah, just that j plus plus. And if then at the end, if j plus plus, and if j equals m at any point, then great. If j equals m, then c out. We do not need the operation and we can just say 0. C out 0 with a new line and not break return. Okay, and now return, and let me see a little bit. Light is not there. If j equals m, then we are done. But if we are not done, then we need some things. L and R. But what are the invariances? we are supposing that in the array A, the first position is 1, 0, then 1, 2, 3, 4, 5, 6, and dot 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 till n minus 1. These are the positions. And when we are saying at some position, let's say m, we are going to put something, then we will put that thing at this current position. Let's say if m equals 1 and we are putting some integer x there, then our array A would look like the original 0 element, the original 1 element, and then the x element, then 2, 3, 4, 5, and yeah, normally till n minus 1. And what are the invariances? The invariances would be that L is not the answer, that the answer is in the range L to R, where L is not the answer and R is also not the answer. So L minus 1 and R equals N. And literally L and R cannot be the answer because L and R are not even indexable in the A vector. And let's look at the limits. If we want to put the element at the first place, then we use -1. Shit. Then we use, okay, if we are putting our element here, then X would come here. Shit, my bad. X would come here. And the original element on the at the Y position will move to the right. Makes sense. So if you want to put an element at the start of the vector, we use m equals 0. But if you want to put the element at the last, at the end of the vector, then we would have to use m equals n, so that the index is n. Therefore, r would have to be n plus 1. And while r minus l greater than 2, that is, we have at least one element in this range. We have at least one element in this range. And in n equals L plus R minus L divided by 2. And now we need a function. Yes, we do. We need to check if we are putting a number at the m location. Is it going to make the B array fulfilled? That is a nice thing to ask someone. Yep, we can only grow one flower with the magic light. Yep, we can only grow one flower. I think if, before implementing this, is this even going to work? And I think this is going to work because wherever we put the flower does not affect anything towards the left, it only affects things on the right. So, shit, shit, it does not affect everything. So, if the current place of the flower does not work, then what do we do? Do we move the pointer to the left, or do we move the right limit to the left, or do we move the left limit towards the right? Shit, shit, okay. Then we move the limit towards the left. Why? There is a reason. Why? Because if the current configuration is not working, then we will move the current limit towards the left, because moving the limit towards the right will not be helpful. If we have all of these flowers and let's say we are putting int maximum value at some location here, and this is not working out. Our b is not satisfied. So we if so now we only have two possibilities, either to bring this int max value to the right or to the left. If we were to bring this to the right, then, well, these elements were not being affected by this putting this value here, and now these will also be not affected by putting this value here, and so in a sense we are losing these elements which we could have saved by using a value here, and this b is now affecting even fewer elements than it did before. Earlier it was affecting this many elements, but now it is only affecting this many elements, and that is not good because we do not have enough. So we want to affect more elements. That is why we should move this towards the left. And one more thing, one more thing. Let's say, so, wait, shit. So we can just put this at the start. We can put the int max towards the start, and we would like to see how much right we can take this. Should this is the like reverse binary search? So this is actually like reverse binary search. Uh, yeah, if we put our, let's have some test array A and B, and also shit, there is the fact that if the length of A is smaller than the length of the B vector, that is you need more than you have, which is not the case. Which is not the case. M is going to be smaller than N, so that is nice. Let's say what you have is 1 1 and what you need is 2 1, and you put a very big number which is 3. 3 is very big. You put 3 here, then this 3 can be used here and this one can be used here, and this is the A vector and this is the B vector. But if you had some other configuration of the requirement vector, this would always work. Choosing a value right here always is better than delaying and choosing this value later. Or if you had 1 and 2, shit. If we had 1 and 2 and we are putting 3 here, then this 3 would be used for this one, but then none of these are filling this. I'm not going to fill this. So putting this number towards the left does not always work. That is something. Yes, so putting this maximum number towards the left does not always work. Hello, how is everything? We can only grow one. Yep. How does the flower position affect anything? It does affect anything. Uh, like in this case, if you were to place the flower at the start, then we will use it to have match our beauty standards of 1, and we are left with these two flowers to fulfill beauty standards of 2, but none of them are greater than or equal to 2. So yeah, that is messed up. But if B was like this, 2 and 1, we would fulfill this 2 using this 3 that we placed here, and we can fill this one with anyone, does not matter. But in this case, when A was 1 1 and B was 2 1, or B was 1 2, then if we were to place the new flower here, then this would work. But if we were to place the new flower here, then it does not work. And that is the sad truth. You got a new cousin today. Like, shit, you are from Texas. Okay. You got a new cousin today. That is pretty nice. Like a new baby. That is nice. Is beauty standards changing as we move? No, beauty standards are not changing as you move. Shit. That is pretty nice. You got a new cousin and a smiling emoji. No, and beauty standards are not changing as we. And by today, you mean in the day. It is at your place very late in the morning, 3 o'clock, I would suppose. So when we have something like this, then placing this extra flower here in the middle works, but placing the extra flower here does not work because we are only going to make one pass from left to right. And in this configuration, in 3-1-1, you cannot fulfill the beauty standards 1 and 2 because the bigger one is here. Yo, he was born 1 a.m. Shit. Sunday, I have another hackathon in Austin, Texas. Shit, yes, Austin, capital. That is nice. On Web3. Shit, I really have to understand what Web3 is. But after getting better at competitive programming, one thing at a time, and that is nice. Like, go to as many hackathons. You have like literally nothing to lose. You are in 11th standard, so you can give as much time as you can to other things. And wait, he chooses to collect flowers at his current position. Right? Wait, shit. Maybe he can fill his B array arbitrarily. Shit, if he can fill his B array in whatever manner he wants, the ith flower among the ones he collects must have. Shit, yes, the ith flower that he collects must have BI beauty. So the second flower, in this case, the second flower that he collects must have a beauty of 2. And the first flower that he collects must have a beauty of 1. So yeah, he cannot fill his B vector as ever he wants. I will have shortage of time now. I will play all day long with my cousin Lord. Yo, that is pretty nice. Hmm. And this is the question that we are trying to do. Flower boy. Bro is now busy, very busy. He will have to take care of a child now. Playing with the child. That is nice. And operation. Shit. Okay. So when he wants to fulfill this thing, uh, 1, 2, and let's say 1, 1. When he wants to fulfill I, he the first element that he can take to fulfill this appears here. and the first element that he can take to fulfill this does not exist. So let's say it is outside here, X. Thus, he must use his one of the his thing to put some to put the plant here just after he was able to pick this one. So that is nice. That is nice. Let's use one of the real examples. 77777. Yes, use a number 7 here. That makes sense. Let's go with this. And I'll bring my cousin with me as well when I visit near Lord. Yo, let's go. And have you watched Kill Tony Trump and Biden one, in which Shane Gillis was acting as Trump and Adam Ray was acting as Biden? That was hilarious. That first show was hilarious, and then they had a second version with the same people, but in Madison Square Garden, that was not very funny. But the first one was literally one of the funniest episodes of Kill Tony, and that was like literally crazy. Okay, here we have two things, this and this. Okay, so what is the first flower we can use to fulfill this one? It is this. What is the first flower we can use for this? 6. It is this. What is the first? Let's write down the indices for these. For this, the index, and let's use one index. For 4, it is index 2, and for 6, the answer is 1, 2, 3, 4, 6, 7. And for 2, we can go with the first element. Hmm. Yeah, let's go with this. Then for 4, it is 2, and then for 6, it is again 7. Okay, and this is pretty messed up. We would like this thing to be in ascending order. Let's make this in ascending order 2, 7, and af when we have 7, we are already at this index. And what is the next flower that is equal to or greater than 2 is at the last index, which is like 9. And then, yeah, we don't have anything. So there are multiple places where we could put this element. Yep, we didn't know. I'll bring my cousin. Trial lead code 1187 is a pretty good question. Okay, I'll do that. Practice. Funny. Yes, that was funny. I'll teach him to code from standard 4. Yo, make him the next John Carmack. Shit. Yes, Dennis Ritchie, Ken Thompson. Yeah, make him pretty good. Or maybe he might want to get into art and he might become the next Picasso or something. That is pretty crazy. You can teach him things from right now, and that would be crazy. Shit, and he wouldn't have to like suffer like this, and he would hopefully be smarter than us, and he would be able to solve questions easily. Shit. 352335812. 46246. to 79. Okay. Yeah, this is the first element we can get for this. For this, we have this. For 2, we have this. And we can put the k at some point. And the thing that is very bad is the last question that we did. This is literally just the second question, and it has been 2 hours. Yo, d- don't act like you would in real life. You can be a bit more polite here, and that would be expected. Be a little more like professional here in the chat. He'll code with me and build Web3 stuff. Yo, CP as in competitive programming. You will start CP from standard 5. I have made complete list. Okay, shit, bro has a roadmap, a strategic roadmap. That is nice. Art of war. Bro is preparing for war now. Sanzu. Okay, the question we did before this, we had to look at the editorial, and I think for this also we would have to look at the editorial, which is just not really good. Yes, CP is competitive programming. Shit, should I thought you were one of my friends, and you are probably one of my friend. 3.js. Don't be be nice here. Not add as moderator. Move these. Your greedy algorithm. Greedy makes sense, but dynamic programming, mm, how would you even define the state of the dynamic programming? Because there are two variables. There is the k, where do you want to put the k, the position, and also, yes, there would be like a lot of things in dynamic programming, a lot of states. And if we are saying that we want to fulfill from the B array, let's say this is our B, this is not good. Let's say this is our B array, and we only want to make this much fulfill. And from the A array, this is A, we are considering, let's say, the first J elements. Our problem is smaller, but the sample space for this, the number of subproblems is very big, because the size of A and B are each 10 power 5 max. So the total state is depending on two variables, and the total DP space would be of 10 power 10 size, and that is too much. Yep. 3JS is trash. Try some different stuff, and many new technologies are present here. 3JS seems to be a real thing. 3JS, what is 3JS? 3DJS. The goal of this section is to give you a brief introduction. Okay, creating the scene. Do you use this to create new things? Images. Shit. Okay. I mean, can't you use WebGL? Because we use JavaScript mainly on the web, and WebGL would be better. I mean, I don't know. WebGL would be like better in performance also because it almost runs on natively. This thing, DP state. No, okay, let's look at the editorial and yeah, kill our ego and actually look at the editorial and make forward progress. And I hope I'm not making excuses for not thinking hard enough. Yeah, 30 minutes is a nice time to take a peek. D. This was D by Cry. Cry is a nice person. And Cry is also from New York, by the way. Cry, New York University, and is online now. That is nice. Has solved 2,600 problems and 165 problems at 1,500 rating. Easy. And when did this guy reach 2,000? Yes, this was the time. 2,000 in 2022. After more than 1 year of giving contests. Okay. And we have 3 months. Yeah, totally possible. It's greedy. Major company have no use case of 3JS. As per I have experienced in many hackathons, many company use standard stuff. 3JS is a trash and it made websites too laggy. Yes, I would say, yeah. I mean, if there is anything, if you are using anything other than WebGL on for rendering things on the web, then it should, yeah, it would be like not as good in performance as WebGL. Yeah, WebGL would be nice. It is greedy. It is greedy. Shit, haven't read. Okay. It is greedy. It is indeed greedy. Okay, let's just uh, read that much and move forward with that. It is greedy. Okay, and yes, when I read this question for the first time, I said that for filling, I said it is greedy, but in the sense that for filling the B vector, we use greedy. It is just that much greedy for filling the fact, for filling the vector B. But where to place that k integer in A, the procedure to find that, I don't think that would be greedy. Yeah, I don't think that would be greedy. The procedure to find out, yeah, where to place k is not greedy. There is a greedy strategy. Every time you see a flower in A, if its beauty is not less than the flower beauty of the next flower you must pick from B, you will pick it. Greedy. The answer is 0 if we run the greedy without inserting a new flower in A and still collect all the n flowers. Yes, the strategy for fulfilling this B vector is greedy, but finding out where to put the k integer is not greedy. And with that, I would have to go to the washroom. I'll be right back in a minute. You, I am totally back. That is nice. Yep. So the strategy for not fulling isn't even a word. For filling the B vector is greedy, but finding out where to put the extra integer is not greedy. Yeah, it cannot be greedy. Now consider what inserting a new flower of beauty K in A will do. It will allow you to skip some flower listed in B. Yes, analysis was by cow the cow. It will allow us to skip one specific flower in B. Okay, okay. As you can place it anywhere in A and just pick it up when necessary. Shit. Okay. Okay. We can use the greedy approach to fill the B vector, and we can use binary search here. Yeah, I was thinking about using binary search like earlier, but I was unable to figure out in which way to use the binary search. But now we can say, let's skip this element, and is our vector getting fulfilled? Let's skip this element, is our vector getting fulfilled? But when we, let's say, skip this, our vector is not, our B array is not getting filled. So we must use some number to the left. We must skip some number to the left, because by skipping this current number, yeah, we are only helping the numbers on the right, and they are not getting like filled. So let's say we are skipping this one, because if we were to skip this, I think we can apply binary search on the B vector. And yeah, we have a bunch of numbers, and we are saying, let's skip this number, and we are not going to look for this number in the A vector. And if, and yeah, and this is going to help only these numbers. And yes, this is going to literally help them to be filled, because it is giving them more opportunities to be filled. Yep, this number is giving them more opportunities to be filled. Yeah, cool. And if by skipping this number, we are unable to help anyone, wait, shit. Let's say in case in A we have 1, 1, 1, and in B we have 1, 1, and a very big number, x, and x is very, very big. So we, like, yeah, let's say, so we will put our left limit here, our right limit here, and if we say we are skipping this, well, skipping this is not going to fill this, right? Then we cannot just move left. In this case, we have to move right, because we want to skip this one. Okay, we can find the biggest number, and we can always skip the biggest number. And if skipping that number is not good, we will move on to the next number, and we will skip that number. But that would be like linear time. We would be almost skipping one by one each number. That would take O of n time. And when we skip a number, then to verify if we are able to fill B or not, that itself takes O of n time. Then the total time complexity is n square, and that is not good. That is not good. So there has to be something else. Yo, history. Shit. Now it is cool. Frames have been dropped. 1.3% frames have dropped. Now it is cool. Only, yep. See ya. I got S11 Ultra yesterday. Galaxy Tab Ultra. Okay, I think you can give those to your cousin now. He would need them. Are you an undergraduate student? So which college and which year? I am in my fifth semester. Not third, fifth semester, third year. And in AKTU, my college is affiliated with AKTU University. My age is 21. And just looking your face at testing, I thought you might have small body wise, but I saw your push-up video. You are big. Okay, thank you. Yeah, quite fits that good. You are quite fit, bro. That is good. Yes, physically speaking. And by the way, I did 1,000 push-ups on 2nd September last month. Not last month, yes, last month, and that was crazy. That was actually crazy. I mean, yeah, 2nd September. That was crazy. I was like literally dead for a few days, and but I was still streaming. That was nice. 1,000 pull-ups. They were crazy. Okay, let's read a bit more because I don't get how can we apply binary search. And yeah, we would have to apply binary search. This will allow you to skip some flower listed in B as you can place it anywhere in A and just pick it up when necessary. Therefore, instead of inserting any new element in A, we can reconsider the problem, not a question, the problem, as deleting some element listed in B. So one slow solution would be to try deleting B1, then running greedy on A, repeat for B2. Yes, that would be n square time complexity. Then we can keep the minimum BI such that greedy would work successfully when deleting that flower. The solution is too slow. Instead, we can compute the index, the minimum index, the minimum J, such that if we run the greedy on this, we will collect some flowers. Instead, we can compute for every index I to M, the minimum index J, such that if we run greedy on the prefix till J, we will have collected all the flowers till I. Okay, let this value be value of index I of B be pi. That is okay. The solution is too slow. Instead, we can compute for every index I, for every integer that we need from to fill our B vector, the minimum index J, such that if we were to run the greedy algorithm on everything on the A vector till that index, and J is the smallest index, we would have collected all the flowers, including this ith flower of integer. Okay, we can forget about the story and just have a pure mathematical model. Let this value for I of B be pi. Okay, do the same for each suffix of A. Do the same for each suffix of A. Okay, specifically, SI be the minimum index. J, do the same for each suffix of A. SI be the minimum index J, such that if we run greedy on suffix this, we would have collected the flowers starting from there that index to the right till the end of the flowers. These values can be calculated with 2 pointers. Now we can delete bj. Okay, so for every value in A and B, for every value in B, we have two things. An index I in A, this is B, and for every value, we have two values. For every value in B, we have two integers. And what this means is this is the minimum amount of prefix of A that is required to fulfill all of these elements. And this much is the minimum suffix of A which is required to fulfill all of these elements. And also we are including the current number in both of the ranges. Yes, BI is included here and here also BI is included. Okay, that is nice. Bro, you also used to watch some. Yes, I did. I once talked to him on Discord. That is crazy shit. That is pretty cool. That is crazy. I have been watching him since lockdown days when he had just started streaming. Shit, I didn't know him back then, but yeah, I started watching him when he was doing all the chess things. Yeah, his chess is like pretty cool. He's a Blunder Master in chess. That is pretty cool. A new title. I'm not that good, but yeah, he's pretty cool. And he's also like he's very smart. He can learn things. He has confidence, and he can learn new things. He can work very hard, and yeah, learn new things. That is what is very inspiring about him. He can learn anything he wants. At least he has the confidence to, and then actually does learn things. So that is cool. He learned chess, which is like one of the hardest things, and he had like no incentive to do so, but he worked very hard and he also won a contest, a chess online contest, which was organized by both his sisters, and that was yeah, pretty nice. That is pretty inspiring. Yeah, the mentality he has is pretty cool, amazing. Okay, so that this is cool. This is cool. So if we were to remove this current element and this index are like opposite sides of each other, then things are pretty nice. No, no, no. If these, oh, okay, let's call this X and call this Y. Shit, everything is gone. Excalibur, amazing. Okay, here we are. Yeah, A and B. And I think we should not include the current element. We have PI and SI. PI is the index in the A array, which is required, the minimum index in A array, which is required to fill this thing. And SI is the minimum index in this, in A, which is required to fill, let's say I is this thing, some number in the B vector. This is the A vector, this is the B vector, I is some position in this vector, and then Pi, this thing, is the smallest prefix of A which is required to get all of these integers, and this Si is the smallest suffix which is required to fulfill this much. And the thing is do we include the current element? I don't think we should include the current element. Don't think we should include the current element because we would be removing the current element. If we do include the current element, I don't think, yeah, let's not include the current element and build the SI and PI vector without that. Yeah, rapping guitar, streaming chess, and a little stand-up comedy. His stand-up is pretty cool. His like printing engineering show was pretty cool. Yes, rapping, guitar, everything, and he works very hard. That is pretty nice about him. Okay, so we already are here. Let's delete everything. And yeah, we don't have any K. What is the second number that we have? N and M. Vector N, A size N, and B size M for int reference X, wait, in X. Replace this with B, fill A and fill B. Then boom. Shit, I was still thinking about Cardane's algorithm, but no, we don't need Cardane's algorithm here. We need to fulfill our B vector. Let's see. For int j equals 0 and int I equals 0, I less than n I plus plus. If ai equals bj, then j plus plus. And if at any point j equals m, then break. And if j equals m, then we got everything beforehand. So that is pretty nice. We can output 0 with a new line. And what do we do now? We have j equals to some number, and yes, so we do not have enough. We need to fill two things. P size m and S size m. Pi means least I in A required to fill B starting from 0 till I. And I is not included. I should not be included because we are considering to delete I. Yes. And Si is the largest I in A required to fill B, not including I, but till n minus 1. There should be a comma here. This seems to be working. But we cannot say beforehand. Let's see. Now, how do we go about filling PI. Excluding the last element. So the sizes have to be +1. +1 and +1. And to fill all the elements before the first element, we need nothing which is represented by -1 and SM when not including the last element, and when we have nothing, that is represented by I+1, uh, n+1, n+1, n+1 is outside the A vector, so that is nice. That is nice. Shit, that is not nice. How would we find the suffix for the 0th element when we are considering to remove the 0th element the first element? Shit. For int I equals 0, I less than n, I plus plus. J is representing the current element in B. And if this, whatever this element is, if AI greater than equal to A BJ, then PJ plus 1 equals I, because we have filled everything up to J and I is the smallest index to do that. If I is the smallest index to do that, and when we are onto the right, when we are okay, we will I guess we will have to start a new search from the right. This is only filling the P vector. I don't think we can use this to fill the S vector. Can't believe I have solved this question 6 months ago. Shit, that is cool. You have been at this for 6 months. Bro, your college didn't force you to come, and how much attendance you have, and how many time you go to college in a week. I do not go to college. Like I haven't gone to college in a few months at this point, and college does expect me to have a higher attendance and go there, but I just do not listen to them. I rebel. Yeah, because this is more important, I think. And shit. Okay, I don't know. Wait, do you know how to do this question? Speaking it out loud. Wait, I don't know why the brain is just not working. Maybe the problem is these are 1500 rated questions, which are tough, and I am approaching these with a mindset that okay, I am good enough. I can solve these. And that is the wrong mindset. Yeah, that is the wrong mindset. Yep, that is not the right mindset. Shit, yes. Yes, but whatever it is, I have to continue. Now, okay. We have to build S suffix, and they are saying these values can be calculated with two pointers. These values can be calculated using 2 points. I don't know how they could be calculated using 2 pointers. They don't make any problem during exams. No, I mean they cannot stop me from giving the final year university exams and SEM exams, which are the most important exams. And yeah, yeah, that is just it. You can just this also depends on which year you are in. I am in my third year currently, and so not so much problem. But for first and second year students, they like are more strict. Just handle B0 and Bn minus 1 separately. Okay, the first and the last separately. For B0, your suffix, if you suffix 1 is not minus 1, then rest equals minimum, right? If suffix 1, that is for B0, if suffix 1, that's all. So it depends on college to college, or we can do it in any college. It must depend on college to college. You cannot just raw dog any college. It depends. Okay, yeah, in IITs they have zero attendance policy, so it would have to go there. So it does certainly depend on college to college. Just handle the first and the last element in B separately. Okay, and for B0, if you suffix 1 is not minus 1, or I guess for, okay, then should that is true if, okay, okay, for if I am removing the ith element from B, then I think we should look at the suffix of I minus 1, the prefix for I minus 1, and the suffix for I plus 1. Then res is minimum. Hmm. Is minimum of res or B0, or for B m minus 1. Okay, this is how to handle the first case and the last case. And for remaining, that is from 1 to m minus 1. If you prefix I minus 1 and suffix I plus 1 is not minus 1, or not just minus 1, if they are like the suffix is to the right, the suffix is greater than the prefix, then the response is this. Cool, cool. That makes sense. That makes too much sense. Okay, and okay, yeah, we can just fill this normally. In I greater than or equal to bj, then pj equals I. And if j, and also let's initialize every value to be like m plus 1. After this, j plus plus. If j greater than m, if j equals m, then 3. So p is filled, I equals n minus 1. I greater than equal to 0, I minus minus, and j equals m minus 1. If ai equal greater than equal to bj, then we can use I, and also let's initialize this value to be minus 1. And if this is the case, we can use the current element, and this is like the rightmost I which fulfills this much condition. Then we will say Sj equals I and j minus minus, and if at any point j less than 0, then break. Now we have, no, before breaking, if we are actually, yeah, if we are breaking, then we have filled everything that there is to fill. Okay, cool. So int res is in max, but we don't even know if the like current thing is possible or not. Yeah, cool. We can use this. And for the first element, let's check if we do remove the first element, what is the suffix for the next element? So if S1, right, this also depends on the size. This also depends on the size, and the size can be equal to 1. So yeah, we cannot blindly initialize this as long. J initialized, just write j equals 0. Shit, bro is too good. But why j equal to 0? I think j should be equal to minus 1, m minus 1, because we are going to go from right to left. And I think the orientation is fine here. Yeah, from right to left. And int max, because I can be very big. I think this is also fine because the maximum value here is 10 power 9, and int max is greater than 10 power 9. Int max is 2 into 10 power 9. That should work. Shit, makes sense. Shit. Wait, let me see. Are there any other bad things? N, M, yes, filling, J, nice. Yep, cool. Now let's go. Check. If we remove the first element, then this suffix, if this suffix is, if n equals 1, that we don't even have to do anything if n is equal to 1. Yep. If n equals 1, then C out, and we have already not exited, so we know bi is greater than C out b0 with in line and return. Now we know at least there are two elements. Now, if S1 is greater than or not equal to minus 1, that is, we are able to fill everything. If we do remove the first element, then this equals A0, or we could say minimum res or A0, which is more standard. And let's check for the last element. If we do remove the last element, then prefix dot n minus 2, if this thing is not is smaller than m, then this is minimum of this and a last element a dot var. And now for in I equals 0, I equals 1, I less than m minus 1, I plus plus. If we are removing the current element, then if by removing the current element p I minus 1 is smaller than s, and this has to be smaller, not equal, because that would mean this I minus 1th element and I plus 1th element, they need the ith element to be yeah, to be good. If this is true, then physics is minimum of this and a dot b stands to be and bi. Now see out depending on this. If this equals in max question mark, then output minus 1. Otherwise, output this with a new line, and hopefully this is correct. If m equals 1. Shit, yes, yes, shit. It's not failure, yeah. Yeah, yeah. I got the A part correct. And if m equals 0. Then why am I being stupid? If because this depends on B. This is going to work in the first try. J equals M, and yes, we are handling when B has only one number and we have is already not exited, then we have to go with this number, and then we are making our prefix and suffix. Yes, this is correct. If we can choose the current J, then this is the smallest I where this is possible. If filled, then output. And when we do output, we have gone through all the J values. We have filled all the PJ. And then we iterate from the end to fill S, J, and S minus minus. And if everything is filled, break, right? And yeah, here we are seeing if we remove the first element and S is equal to minus 1. Initially, everything is equal to minus 1. And if we can remove all the elements to the right of this current element, then okay, it is a possible value for the response. And if we remove the last element and we can fill all the elements up until the last element, except the last element, then that is also a possible response. And for each I, if we remove the I, are we able to fill all the elements, fill the left to the left of I, and are we able to fill all the elements to the right of I without overlapping? Then it is also a possible answer. So this should work. This should work. This should work. This should work. This should have worked. This should have worked. Bro is just too good. Bad rating right now. Shit. Let's see. It should work mostly. Oh, you use Goon DP. What is your favorite character? Killua. Shit. Gone. Gone. From Hunter x Hunter. Code. Profile/this. Shit. That is crazy. That is crazy. Shit. I was expecting like 1700, 1800. Okay, okay. No one saw anything. No one saw anything. Shit, I was literally expecting 17, 1800 thing there. And where did the YouTube thing go? No one saw that. Don't worry. Don't worry. Shit, YouTube is lost. Okay, we can work with this. And yes, do not watch this movie. This is a French movie, Martyrs, 2008. Do not watch this. He's so AV, out of bounds. Bro, your ID gave me anxiety. Will I be able to reach 2000? Because yeah, you clearly like this question is very like easy for you, and like you know exactly what to do, and your rating is not too good, currently speaking. And shit, yes, I will reach. I will increase my rating. I can get better, get good confidence. Out of bounds is, of course, wrong answer is better than out of bounds. Okay, here we say one is no. For this one, we are giving three as the answer. That is kind of messed up. Wait, we are giving four as the answer, but three could also be the answer. If J equals M, why are we not outputting zero here? Why do we say one in the fourth case here? Why do we say one again? Wait, don't we? Are we not returning? We are returning. We have just one test case, and I just give contests randomly. Shit. Bro randomly gives contests and is able to solve 15 rated questions. That is crazy. You know, bungee jump have property of both rubber and gum. Greater than equal to. Greater than equal to. That should fix this. And as for the other error, this one, I think this has to be less than because these two numbers cannot overlap because we do need the ith number. Yeah, we do need this and we do need this. Okay. If we are removing the last number, here the answer is 3, but we say 4. Here answer is 3, we say 4. So for 5 is pointing here, 4 is pointing here, and 3 is like pointing quantum outside. Prefix m minus 2, that would be 4. 4 is getting a little colder. Just a minute. AI greater than equal to BI, mostly the favorite characters below. You're solving from TLE sheet. Not right now. Right now we are solving from like randomly code forces questions. And just a minute, 10 seconds, 5 seconds. Now better. Kilua is better. Shit. Gone. AI greater than equal to AI. I messed up somewhere else also. Here, this is correct. Here, this is correct. AI greater than equal to BI. Sj equals I. We need I. And here, PJ explains. PJ explained is I. Okay. And J plus plus, J minus minus. Wait, what you were saying? Yeah, that one was good. I did that one. And mostly the favorite character is Clover. Like, it is one of the animes where the co-protagonist is more liked than the main character. Like One Piece, Zoro. Zoro no Zoro. Zoro is pretty cool. Less than M minus 1. We are not going to the last character. Uh-huh. Let's output P. And there is a like function for that. One. And this is the one that is messing up. Okay. Yes. Okay. The problem here is this has to be N. And also will be initialized. This has to be N plus 1. And let's stop this. Cool. This is working. This is working. Now we can submit. But before submitting, we will have to do something. See out your prefix and suffix. Now it is working. Let's see what the indices are getting stored. Yeah, now it is working. Yeah, I was looking for M instead of N. Now it is working. And now before submitting, let's delete and rewrite int N and M. Take in N and M. And now we will fill our vectors A and B. A has N elements and B has M elements. And for int reference X in A, fill all the X and fill the B. Now int J equals 0. We will not reinitialize J later also because yeah, we learn from our mistakes. Yep. Now let's fill J, fill I, fill B. I smaller than N, I plus plus, and if AI is greater than equals to BJ, then J plus plus. And if at any point we have J equals M, not M, we break, and if J equals N, then C out 0 with a new line and return. And after this, what do we do? Yep, after this, we need to see if, yeah, if M is 1. The test case, if M is 1, then C out B 0, the only element in B, yeah, the only element in B, and return. Now we will create the suffix and the prefix. Int prefix size M for each M and suffix size M. And now you fill the prefix. I is smaller than M. I plus plus. No, that is wrong. J equals 0 for and I equals 0. I less than N. I plus plus. If AI is greater than equal to BJ, then PJ, again BJ explained, is equal to I and J plus plus. And if at any point we have J equals M, we will do break the current thing, whatever it is. Yep. And after this, we have to fill the suffix, for which we have to initialize, not initialize, reassign J to be M minus 1 and I equals N minus 1. Yes. And I greater than equal to 0, I minus minus. And if AI greater than equal to BJ, not PJ anymore, BJ, then SJ equals this I. This is the rightmost I where this thing is possible. And J minus minus, if at any point, if J equals or smaller than 0, then break. Now, suffix and prefix are filled. Now, we take care of the cases when if we are removing the first element and if we are removing the last element. In maths, we're stuck in if we remove the first element, then suffix of the second element should, yeah, also we have to initialize their values. This has to be initialized at n plus 1 prefix, and this has to be initialized as minus 1. Now, if the suffix is not equal to minus 1, then we can use this minimum of res, and what would be the b value here? B0. And if we remove the last element, then prefix of n minus 2, if that is smaller than n, then we can use it. And rest is history. Rest is b dot back, the last element in b. Now we iterate for int I equals 1, I less than m minus 1 and I plus plus. If we remove this current element, then all the elements prefix I minus 1 should be smaller than prefix I plus 1. Suffix I plus 1. They should be like able to do whatever they want to do. Res equals minimum of res or the current element, which is bi. Cool. See out depending on res. If res equals int max question mark, if that is not yes, but output minus 1. Otherwise, output res, whatever it is. And this should work. Compiling works. It works. Es funktioniert. Es ist sehr gut. Okay, it does work. That is pretty nice. It is cool. Shit, cool. Yeah, it is basically used for hero and villain. Bro is into his anime yapping. Anime are pretty cool. And we have done this, like literally. Thank you. We got this. These are Greek words, like it means first actor and okay, first actor and against actor. Antagonist and protagonist. I don't know the actual meaning of protagonist and antagonist. There is some more terms. More terms. Never tried to know what these means. Okay, cool. Greek. They are Greek. That is nice. I didn't know that. Like it means first actor is protagonist and the second is antagonist. A or Walter White is anti-hero. And we have only done 2 questions. And we are already at the 3-hour mark. This is not really good, but okay. Okay. The main thing is we will not stop. I will continue streaming every day. And yeah, I expect to grow. Even if I do not reach 2000, I will become really good. Yeah, I will become really good. Like better than currently I am. And yes, this would be the end of the stream for today. I think this has been enough. And I would like to take a walk now. And if there is like anyone would like to say in the chat, now would be the time. Cow the cow. Let's stalk someone who is much better. Shit, 1897 currently and 1965. Last contest was just this last one, and bro lost a few rating. Cow the cow. And bro has 67 friends, and now he has more than that. And bro has solved 1054 questions. Okay, and most of these questions are here. He has solved a lot of 1400 rated questions. 1200, 1300, 1400, then 15. Okay, this is nice. This is like good stats. Very insightful, I would say. So he grinded questions from 12 to 1400. And how long has he been? He has been here for 2 years. Okay. And okay, shit. He reached his peak here at 1326. He was pupil and almost a specialist, but then he became newbie again. And now bro is 1897. That is amazing. That is pretty cool. Then he came back and he started grinding, became a specialist, and he gave contests 23 July, then November, August, August, September, October, 3 months ago. 3 months, okay, between these two contests. That is okay. This is pretty cool. And in the last contest, he solved 4 questions and his rank was 800 and he still lost some rating. That is crazy. That is crazy. Bye bye. I feel him. Bro feels him. Last Div 2 B was really good math problem. Last Div 2 B. You mean the education round? Yeah, that was nice. Shit, what even was that question? Deck of cards. Yes. This was good. 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 Yes. Shit, yes, this was good. Yeah, this was good. Shit, why did okay, he went back and did this question 2 days later when he became a expert again and not a specialist, not a candidate master. That is nice. Pro solved it in 15 minutes, but ask taking input as integer, so wasted 10 more minutes. Okay. Yes. Wrong submission made 10 more minutes. Yeah, right. That was bad. Yes. And bye bye. That was it for today. And thank you for being here. Bye.